Okay, so this talk is going to be on debugging Java applications on Kubernetes. It is 2022, and we're the Chicago Java Users Group. Hi, I'm William. As Mary described moments ago, I mostly do operations work. During the day, I make big data applications run for Optum Digital. We are a part of United Health Group. United Healthcare is the company that most people have heard of, the insurance company. I also do development work sometimes, work on a couple of Apache projects, got some side projects, that sort of thing. This talk is going to be kind of in the middle of those. DevOps is a really neat term that folks have been using and probably overusing over the last several years, but this is squarely in the middle of that. This is, what does it look like to take code that you have written and get it to meaningfully run on servers and be available to the world? What is that? I have Twitter, I have a website, et cetera. The first question that I always get is, will these slides be made available? And the answer is yes, they already have. Here's the link. For those who are watching or recording, this QR code should still work. If not, email me. I'm happy to talk about slides. Quick synopsis of what it is I'm going to talk about. If all you get is this little bit, you will be getting most of the gist of this conversation. There are a handful of commands that you can run that are built into Kubernetes that make it easier than you expect to access and debug and get information about and poke at and execute things with running programs that are running in a Kubernetes cluster. Coopctl exec allows you to run commands. An example that we're going to do is telling a Java application to create a heap dump. You can also use it to just get a shell, to just log in and wander around and interactively inspect applications that are running. You can copy files into and out of containers. You can copy out a heap dump. You can copy up new versions of like Python scripts you're iterating on. We're going to talk about the heap dump example. You can do port forwarding, which is wildly powerful, to get remote access at a network level to sockets that are running in those containers and just in the cluster kind of in general. We're going to see an example of connecting up JMX and remote debugging to some Java applications that are currently running. And then there's an entire industry that is stood up around these technologies that is called APM, which is Advanced Performance Monitoring, Advanced Monitoring of various kinds. Providers like Datadog and Dynatrace and Apache Skywalking is an offering that you can run locally that use these same powers and these same commands and these same actions to watch your application and do debugging based on things that you've done in the cloud and other kinds of really interesting sorts of tactics that they can take. What I'm saying is that understanding kind of what it is that they're doing under the covers provides you kind of a window into what the possibilities are. And I think that's really cool. So let's talk about debugging Java a little bit. This is something that we've done over the course of years. We have a Java application that we kind of wish we knew more things about. And it's maybe doing something we don't want. It's maybe doing something that we want more information on. And there are lots and lots of different things that we can do. Java as a platform and Java as a virtual machine and Java as a language has been around long enough to where we have a lot of different really cool ways to know what it is that our applications are doing. And we have ways to discover this that are more powerful, in my opinion, than a lot of other contemporary languages that might be an alternative to Java. We're going to look at doing things with heap dumps, with remote and local debugging through sockets, and then the APM stuff that I mentioned a moment ago. For this talk, I'm going to assume that you've been able to install Coopctl, which is the control the control application for Kubernetes. That you've got some amount of Kubernetes running, you've got an application deployed there, permissions are set up, that sort of thing. This is there's a lot of work that goes into that. But once you can do that, once you can deploy your Java application into Kubernetes, all of this kind of falls pretty quickly. I'm also not going to talk about the super duper basics of JVM debugging. I'm going to assume that once you can get in, you know what it is that you're doing and you can figure out variable watches and you can figure out once you're able to look at what the heap is doing, you can figure out the things you need to figure out. And then lastly, my examples that you're going to see here are running on a version of Java and a version of Kubernetes that is wildly old, and by wildly old, I mean it's like maybe 3 or 4 months old at this point. Java 11, which was only very recently overtaken by Java 17, is the long-term release. And Kubernetes 120, which is a couple of versions behind now, but not too bad. Importantly, as of today, there's no changes to what it is we're talking about in any newer version. So let's talk about Coopctl or Coopctl, which I think Coopctl is just an absolutely adorable way to say that. And I would strongly recommend that kind of adorableness in our daily lives. But Coopctl or Coopctl or Coopcontrol, I guess, is a way to interact with the API for Kubernetes. Kubernetes is a persistent application that starts Docker containers and also deals with distributing them across multiple servers and also attaching storage to them and creating networks between them and thinking about dependencies between containers and dependencies between applications. And it's a really interesting, really intricate piece of software. And the way that you control it, the way that it is actually managed, is that it exposes an HTTP endpoint where you can post and get YAML documents back and forth that have certain schemas that describe commands, that describe things that you want them to do, and back and forth. Kubectl is the nice command line client that talks to that API. So it exposes things like ask your Kubernetes cluster about what containers are running. And then also things like, please tell the Kubernetes cluster to make a change, to update an environment variable, to restart an application, or to do port forwarding or execute a command, things like that. You have other options other than Kubectl. Lins is really cool. K9s is really pretty. They do the same thing that we're going to talk about in this chat. They are generally prettier, and everything that they are doing is something that we're going to talk about, but they just have kind of nicer wrappers around it. Understanding what it is that's actually going on is kind of the point of this chat. So let's jump right in. I said we're going to talk a little bit about heap dumps. I'm not going to get too deep into it, but here is my vastly oversimplified understanding of what the memory space inside of a Java application looks like. You've got your meta space, which is very meta and very awesome. I'm sure there's some JVM internals in there, some strings maybe, I don't know. You've got the heap, which is where all of my objects live. And it turns out that Java as an object-oriented language and the JVM as an object-oriented virtual machine, most of the cool stuff that happens, most of the interesting things that go on are objects. And so they all live in a big heap, which, sure, totally. Then there's also some off-heap space where other things can live, buffers can live. If we're doing anything that's really intense, like talking to graphics cards, that might be off-heap. Anything that we are talking, anything that we wrote our own C files for, that's probably off-heap memory. But by and large, the most interesting part is the heap, and that's what we're actually going to go get. The power of a heap dump is that you take this entire big cloud in the middle, all the interesting business objects, all the things that are doing stuff that your application cares about, and you write them out to disk. Just write it directly to a serialized file that you can go get, you can look at, you can parse through, you can evaluate, see what it is you can do. The way that can happen is by asking your JVM, asking your Java virtual machine to write that write that big memory space, write it to the disk. And the way that we do that is by executing a command that pokes it, does a little interprocess communication, and sends it a signal or writes to it over a socket. But importantly, we're running a little command next to it that says, please do this thing. Please run a heap dump. Kubectl exec is the way that we can say, dear Kubernetes, you are currently running a container of some kind. Please run this command inside the context of this container. So inside of the same C group. So inside of the same CPU tree, and inside of the same context, and inside of the same network. All of the little stuff that we believe that is a meaningful boundary of the container. Please run an application inside of that, and let me know what happens, or maybe do some interactive stuff back and forth. So one great example, PS, can show you what processes are running and their process IDs. So let's do an example. Let's take this out of slide land and actually run ourselves an application. For PS, I have an interactive Kubernetes cluster that I hope is going to work. And if not, I have videos of most of these things. But what I want to show you is here's your kubectl command. And I want to say get pods. Show me the pods that are running inside of Kubernetes. A pod in Kubernetes parlance is a collection of containers that do the same business thing. So when I say the same business thing, I mean like you can have a web application that is next to a thing that is getting secrets for that web application, or that is next to a container that does, that does container-to-container encryption and like network munging. What it does not mean is an application and its database and its whatever. Those we would want to separate so that we can scale them separately. A pod is a collection of one application and then the necessary containers next to it to get that application to run right. In this example, I have this delightfully named has a leak application that is running. It's running a little web service, and that's the only thing it does. There's just one container that is running a Java web application that is based on Payara Micro. It is, you'll see that here in a little bit, but this is the only container that is running. I can tell kubectl to describe this pod, describe that pod, and it should think about it for a moment and then come back and tell me a whole bunch of things about here's a volume that it has. Here are all of the very secret environment variables that are going on with it. Here is some places that it lives. Here's the image that it's pulling, a bunch of different fun things. Yeah, so a bunch of fun information there. Some IP addresses. Importantly, we shouldn't have to know about most of this stuff. The delightful one that I really like here is this JVM args that talks about kind of like some setting ups of the JMX and some of the remote debugging stuff. We're going to talk about why these are important here in a little bit. But yeah, so we were talking about wanting to run PS. So if we say kubectl exec, I'm going to add the magic letters -it. I'm going to say the name of the, no, not that. That's the name of the Zoom that we're in right now. I'm going to say the name of the pod that we had before. So this, that, 2 dashes that separates the kubectl stuff from the command that I'm about to run. I just want to say PS. Let's see if this works. It might, it honestly might not. It does. So what happened was kubectl, this kubectl is an API consumer, and it sent a command in YAML format, posted it to a WebSocket that said, please execute against this container, against this pod, the command PS, and give me back the results. And so it did. And PS running inside of that container shows there's just one thing running. It's the Java application. But then also there's this other command, the one that I just framed. Just like anytime that you run PS inside of a Linux or a Mac terminal, you'll see PS in the list of its own output. So this is the only application. Importantly, PID1. We'll use that in a couple minutes. So if I go back to present, of course it starts over. Okay, so that worked. And here's what it is exactly that we said. We said kubectl, which says, please run this. -it makes it interactive. We can talk a little bit about what that actually does under the covers if you really want. Pod is the one that we care about. That split the commands. And PS, and that's awesome. That's a great start. So how can we use that to make a heap dump, to do something interesting? Well, we can use the same notion. And instead of just passing PS and saying, like, show me the list of programs and their IDs, processes, I want to actually execute something kind of fun. So I'm going to execute J command against the process identifier that we found a second ago. And I want it to say, and I want to tell it GC heap dump, and then here's an output file. And so the structure of this command is exactly the same. kubectl is a way to say, dear Kubernetes cluster, please do this thing. The thing that we want it to do is to execute, to make it interactive. It's a pod that we care about. And then here is the rest of the command that we want it to run. So let's see what it is that does. All right, so same sort of notion, but I want J command. I want to pass it process ID 1. And I want to say gc.heap dump tell it to do a heap dump, and I want it to do out.hprof. We'll say that. And so this should run, hopefully, and run, and it'll think about it, and it'll say, oh, hey, here's that file. I have created that file. It is 1, 2, 3, 4, 5, 80 megs long in half a second. And that's great. So here is the 80 megabytes of all of the objects that are currently running. And I can take that and I can look and say, oh, like here's the state of the memory in my application as of this moment. But we still have this problem because /temp/hprof, this is all running inside of the container. So the scope for what /temp/out, this actual file is not on my laptop. It's on the server up there. It's inside of the container, still in my Kubernetes cluster. How can I get this very cool file down to my laptop so I can poke at it? Let's see. Scroll. So we got the file. So how do we get it out of the container? Now, in the past, in times of old, whenever we do this sort of thing, whenever we have a heap dump that's generated by a Java application, usually on our on-premises big iron, I could drop it on my toe and dent it and then almost get fired because I broke a server, sort of ways. We could take this file and copy it to an NFS mount or send it up to S3 or copy it over to a file system somewhere else. And we've been doing that for years, and that works, and it still works very well. And you can send a command up to your container that says, copy this to some other location. That's still a totally useful idea. And for certain examples, that's actually going to be the right answer. But there's an easier way for something like this. Kubectl CP allows me to copy files in between a running container in Kubernetes and my local machine. It is a super, super compelling little command that I am super happy that exists and I wish more people knew about. You can copy files up and down, and it's just the same sort of command structure as SCP or some of these other like copy commands that you may be used to on the terminal. But the idea is that you are copying literally between a pod location and then a file in that pod to a file on your local disk. The location of the file that we care about with respect to the pod is the file that we just created, and then out.hprof is the local file. So let's give that an example, and if not, I've got one recorded. So we've created this thing, and I want to say kubectl cp, and here is the pod that we're talking about. Colon separates the name of the pod from the file system in that pod. The file I created is /temp/out.hprof, and I want to copy it to out.hprof in my current directory, which is this k8c directory. So let's copy that. This is 80 megabytes, and it is probably going to work. We will see. Importantly, like you'll note, there's this weird like tar removing /remember names. What it's doing under the covers also is still just an exec. Like it's executing this command and then reading the output as just binary data and then directing it out over to a file. But the important part is that like we can execute commands inside of Kubernetes. We can see their output. And so that's enough to do things like file manipulation and copies and reads and writes. As long as I can like stream data back and forth and I have some control over what happens on the other side, I can create files on my local system that are exactly the same size as this heap dump that was created. And if I want to, I can open this hprof up with something like mat, which clearly did not do this beforehand, but yeah, so I can open up this file and take a look at it, and we'll kind of see some of the kind of neat ways to do that here in a moment. But yeah, this is effectively a snapshot of what the memory of my application looked like. And now I have it. Now I can wander through and see, oh, is this structure perhaps too large for some bananas reason? Is it doing something else? And we can take a look and see what's going on there. So if we do, okay. So we copied, and that's great. So I showed there a series of things that worked. And just like anything that works, sometimes it doesn't work. So what are some things that can go wrong? First thing that goes wrong sometimes that people get confused about is that when you're running kubectl exec, what you're sending it is not something that goes to a shell. So even though a command works correctly when you type it in your local terminal, that doesn't necessarily mean that it's going to work exactly correctly when it gets run in Kubernetes. And the reason for that is because it is executing the command, it's executing like literally the file that is being expected. Like this first thing has to be a file that it can find. And then it can like load that into memory and then run it. But that also means that you don't get a lot of the weird built-ins that you might be used to if you have a shell. So like CD doesn't work. And like referencing $home doesn't work. There are some commands that still do, but a lot of them don't. One of the ways you can get around that is by saying the thing that you want to execute is a shell. And then you can pass commands into that. And so in this example, the command that is actually being run is bash. It is literally the shell. And then we want to give it a small script of things that we want the shell to do. But that line between like executing a file, executing an executable versus executing like a series of commands in your shell, some of which could be references to other files, like it's kind of weird and kind of subtle, but like there's something to kind of keep in mind is that sometimes you will see like this doesn't exist or this doesn't work. And it's a big and scary error, and it should not terrify you. I think I'll show an example of that here in a minute. What can go wrong? You can run out of space. We looked at an 80 megabyte memory heap dump, but containers don't always have a lot of local disk because very rarely do they actually need it. Like most of our applications don't write things locally. They talk to a database or they hit some web services or they do some other stuff. They don't really write a lot of stuff locally. One of the ways you can deal with that is you can add a bunch of local disk to your container, which is totally a valid option. In a lot of places and in a lot of ways, especially as containers themselves get smaller and the applications get smaller and need less memory, like having an amount of local disk in your container by default is reasonable, is not bananas. Other things you can do, you can attach external storage. Kubernetes is pretty good at being able to coordinate like dependencies between your running applications, between your running containers and other resources. So in particular, storage volumes. It knows how to do things like attach NFS mounts. It knows how to like mount S3 buckets and other kinds of like local storage and things like that. You can totally do that sort of thing and write stuff out there. If you're going to create local disk and you're going to just make your container bigger and say, please like make sure that this has enough space, it should at least be a little bit larger than the amount of total memory that you give it. That way, because the largest that the heap is ever going to get is equal to the amount of memory that it has. Like it reasonably can't go larger than that. And so being able to write that whole thing out to disk with a little bit of margin for error on both sides is probably a good thing to do. That's especially important if you want to do heap dumps by default. Like every time your application crashes, you want it to write a heap dump, which is an option that's been around in Java forever and is super duper useful. Make it easier on yourself. Write it out to a storage volume that is relatively large and is also exterior to the container. If you write it locally to the container, there's like weird things you can do to like get files out of containers that are stopped in Kubernetes, but it's really hard. It's super hard. It's like time limited. Just do yourself a favor. If you want to do that, which is totally a valid option, have a location for it that is mounted as a like NFS mount or is mounted at, like written to an S3 bucket or something. Keep in mind that like when that happens, your container is going to be low on memory. So don't have like a whole bunch of stuff that has to get started up whenever it wants to copy things out. The NFS mounted option is generally the best for, especially if you have very large, like Java applications that have very large memory that you want to be able to dump kind of like by default, like anytime that it crashes. If you do that, the NFS stuff, file system permissions get really weird. Because remember, your container has its own view of what a user is, and it can have its own view of like access control lists on your file system. Those will very rarely match inside the container and outside. Even root, like root inside of your container may not be root on the outside, and it may or may not actually be able to read files or write files that are outside of itself. SE Linux makes things complicated. Keep that in mind. What I'm saying is that like, be aware that your file system inside the container and your file system outside the container, even though it's like reading and writing the same bytes, that might have different meaning inside and outside of the container. Be sure to test. Like, do a thing where your application in your development environment crashes and make sure that it knows how to write its heap dump to the right place. Do it in prod even. Make sure that your applications can survive being turned off, being like going through a crash loop in production. It's a good thing to do for exactly this reason. When we talked before, we talked about pods, the notion of a pod inside of Kubernetes, which is the series of containers that are doing the same business thing. So like running a web application could be an example of a pod. If Kubernetes can't quite figure out which one the main pod is, then running simply like kubectl copy and then a pod name may or may not work if it can't figure out which container. If you've got several containers that are running in the pod and it doesn't know which one you actually want, sometimes it'll guess, sometimes it's wrong. You can override that. It is very rare that I've seen this go wrong, but like I've seen it before. It can get confused. It can try to copy files in and out of your Datadog sidecar, or in and out of your secret manager, or in and out of your Istio overlay, something that doesn't actually have anything to do with your application, but is running alongside of it. Yeah, you can use your human abilities and the -- container option to override that. So we talked about heap dumps, and those are really fun. But like heap dumps are only one kind of debugging, and this talk is going to talk about a lot of kinds of debugging. So let's talk about the next one. Let's talk about JDB. And JDB is the Java debugger. It is a very similar sort of command to C debuggers. So GDB is the one that it looks most like to me. It's useful. It's very cool. It's very powerful. It is inordinately complicated. And by inordinately, I mean, I don't understand it. Like there's like this help text on the right over here in tiny, tiny letters that nobody can see is the actual like help text for JDB. There's a lot of stuff in there that that is super complicated. Almost everything that you do with debugging is through an IDE at this point. And the IDE is executing these commands under the hood. And if you wanted to, you could totally type this stuff out, and there are certain contexts where you would. It's just a little bit weird to do. But the concepts are all still there. So let's talk about like ways that you could run something like JDB or a different debugger or whatever other application that you want. If you can run arbitrary commands, so PS, and we can run JCommand, and we can run a couple of others, and you can even like run things that read and write files, do that tar thing we were talking about earlier. How about can we just like run a shell, just so I don't have to like know beforehand like what commands I have to run? And the answer is totally. And when you run a remote shell, it's a little bit more complicated because there's like, you've got to do the interactive thing. You've got to think about the size of the screen and things like Vim wants to be able to know what the top of the screen and the bottom of the screen are. But like anything that you want to do is totally possible. Like that's just configuration, and then you're sending data back and forth. Like we can do that. It totally can. You can load in a bunch of different like kinds of tools that folks can enjoy. strace, truss, netstat, anything that you want to build into your container that's a tool that you particularly like, you can totally do that, and you can execute it and play around with it while things are going on. You could go so far as to cobble together an entire IDE. You could seriously like package up your application with a full IDE and run it. And then if it ever breaks, you can like log in and like execute the IDE and see what's going on. I'll tell you, don't do that. That's not a good idea. It's a bad use of resources, and I'll show you a better way to do it here in a minute. But you could totally like conceptually, you could do that. Like that's a thing that you could totally do. So let's take a look at that. JDB. Let's see if I can remember how this works. So we've got that kubectl exec, and we've got IT that makes it interactive. And we've got this. We've got double dash, and I want to say the thing that I want to run is bin bash, because bash is my very favorite shell, and bash is, it's a lovely shell. But oh no, I got a horrible error. And this is the kind of error that you'll see if you try to do like cd. it'll tell you something kind of similar, which is that like, I can't find this executable. I can't find an executable named CD anywhere. In the same way, this container can't find bin bash anywhere. There's no file called bash. And like, that can be okay. One of the major differences between kind of the ways that we've done Java applications historically on big servers that are like fully, like has a lot of packages and every possible different alternative is covered. And like containers is that the container wants to run your application and doesn't want to run a whole lot else. And so a lot of stuff gets stripped out. And so you may not have your very favorite shell. You may not have bin bash. You probably have something. And in this case, with this container, we have sh, which is the older version of bash. And there's like some subtle differences, but it's more or less the same. But the important part is that like the files that you expect will probably be there. But if they're not, it looks scary. OCI, runtime, exec failed, container linux.go. But it's fine. Like just read a little farther. Bin bash, no such file or directory. Just like, oh, it can't find that file. Like, that's okay. Make sure that this is the file that you actually want. So we've got bin sh, and this -it makes it interactive. So I can do ls and I can look around and see it's got color. It's got, I can do ls-l. I can do vi. I think I can do vi. I actually don't know if I have vi in here. Oh, I do. And it works. And like, it knows how big my screen is and like lets me do all sorts of stuff. I can edit things. And it's really, really kind of compelling like that. Yeah, it's a full shell. It's a full shell that I can do full shell stuff with. For instance, JDB. And if I remember right, it's JDB-attach. I want to say that's it. Nope. What is the JDB attach command? It's not one, it's 5,000, isn't it? We talked about the wrong shell. We talked about that. We'll talk about that in a second. No, that's before. What? Yeah. Super sorry, friends. 5,000? No. Close 5,000. God bless it. Okay. I will remember this here in a second, but for now, let's take a look at this video. Coopctl get pods. And there's our pod, Coopctl. Execute that with bin sh. And we get back in there. And the command we want is JDB something. It's JDB-attach something. Is it 6,000? 6,000. So close. Okay, so it was dash 6,000. Yep. That's right. 5,000 is the JM export. 6,000 is the. So let's take a look at what that was just doing. We took a look at the command line. These are all of the options that we saw in that describe pods thing, and we see that JMX is turned on port 5,000, and JDWP, which is the Java debug wire protocol, is on port 6,000, not 5,000, which is why this didn't work. But I should be able to type 6,000 and see it does. It actually attaches. And then I can take a look, just like the video showed, and take a look at the threads. And here are all the threads that are running inside of my application. I've got all of my Payara executors scheduled tasks. I've got this very important HTTP listener that's doing stuff. Hazelcast, which is the clustering libraries, are all running in there. And I can do whatever fun stuff I want to inside of JDB. Here are all of the options I can do. Stop it. I can set breakpoints. I can do traces, all sorts of cool stuff. Wonderful. So let's look at Where did that go? Where? Okay. Okay, so what can go wrong? We talked about having the wrong shell. It is a very scary looking error message, but worry not, it is totally understandable. Just make sure that you are referencing the command, the executable file that you believe that you want to be referencing. Other weird things that can go on that I've seen that people have problems with, even if you run a command that you swear is there, that is absolutely like here's literally this file called pgdump, which is a delightful command that sometimes you want to run to take a look at your database or to do a database, freeze it and then restore it in dev or something like that. You can come up with this weird not found error. And the reason for this is not that it can't find pgdump, it's that it can't find some of the libraries that pgdump is compiled against. And this happens to me occasionally when I'm using a container that is designed to be very small from a project called Alpine. And Alpine popularized the use of micro C as a set of C libraries, as a C user space. But most of the applications that I run are on the GNU project, the GNUC or glibc. And the differences between those cause weird problems like that, because that's a really weird looking problem, right? It's I swear to you, this file is here, but it can cause very mysterious problems like that. Make sure that whatever tools you're using exist in the same user space as the container that you want to actually execute them in. That is frequently going to happen, but it happens surprisingly often that someone's oh no, Alpine makes smaller containers, which they do, but all of that smallness, all of the restricted size of the container and packaging fewer dependencies and things like that does come at some kind of cost. And that cost is occasional weird errors. So we talked about so there's remote monitoring. And if you squinted carefully at that JDB command that I couldn't remember, the thing that it's doing is it's talking over a socket. It's talking over port 6000. So there's a network connection that's happening, even if it's local, between that JDB command and the actual running Java application. And further, JDB is fun or whatever, but man, is it complicated? And man, am I just not very good at it. But I have a lot of really cool tools on my laptop that let me do way cooler stuff. Is there a way for me to talk on the network, talk just over that network connection up to the ports that are listening, the secret ports, the debug ports in my application, the JMX port for management extensions, so I can get weird JMX metrics and I can send commands up to that, or JDWP, so I can do the full debugging stuff that we were just doing there, but in my IDE. Is there a way to connect that to my laptop? And the answer is yes. So you saw some of the options that I had passed into the JVM, and the default JVM, the way that it decides to expose some of these debugging ports is through this long list of options that are kind of weird and esoteric and way longer than they probably should be. But they were, they've been decided years and years ago before this kind of use case was popular. You turn on your JMX remote, you turn on RMI on the same port for some reason. You tell it, don't worry about local, don't worry about authentication, don't worry about SSL. Hey now, what's this authentication false and SSL false about? The subtleties of deciding whether or not turning on unauthenticated debugging on your production instances, think about that. I'm not going to tell you not to do it, and there are certainly times when it's a better and worse idea. There are ways to do it better and worse. There are ways to make sure that it's limited down only to certain subsets of the population. It is a large and interesting and intricate topic that I don't have time to do appropriately, and so I'm not going to try it all. What I'm going to tell you is be thoughtful. Before you turn this on in production, find a friend and go through this with them and make sure that this is a joint decision. It's not just something that one random person turns on. Keep in mind that anyone who gets access to these debug ports has full control of your app and can see every piece of memory, can execute arbitrary commands. It's super duper powerful. So be careful. For remote JMX and this kind of remote debugging in general, we can port forward. Because we know that these are just regular TCP ports, 5,000 and 6,000, we can use the kubectl port forward command to bind a network port in Kubernetes to a network port on our machine, which is wildly powerful. It is visible inside of the pod. It doesn't have to be exposed. It doesn't have to go through load balancers. It is like a direct network communication to a single container running in Kubernetes. It can match a network port in the cluster to a network port on your laptop and just keep them in sync. And it is probably the most powerful thing that I've seen in kubectl. The command itself looks very similar to what we were doing before. This time, instead of executing a random executable or copying a file, we're saying port forward, please port forward. We give it the name of the pod and we give it some ports that we want mirrored on our laptop. Make it to where that port that is on the laptop, anything that is sent and received, ends up in the container on that same port. So let's take a look. Let's talk about this real quick. So the environment that I'm about to show you is because we're port forwarding. That means that like the network stuff that exists, because we're mirroring it, we can do all the same networky things that we would do like with JDB or with those, like the heap dump commands, J commands, stuff like that. All the stuff that I talked about, packaging into your container, you can just run it on your laptop and then have the effects of it go across the internet to your container and have those effects happen there. So you can use your own IDE. You can connect up IntelliJ, super nice IDE. You can connect up NetBeans, super nice IDE. You don't have to package everything to debug your app into the application, which itself makes it pretty powerful because then you can shrink down the application, that is running in production. Like you don't have to have quite as much stuff around there. And your debugging environment is clearly the best. It doesn't have to look exactly the same as another person that you work with. It doesn't have to look exactly the same as somebody else, right? It can be your debugging environment, and you can use your favorite tools to do that kind of debugging. So let's take a look at what that looks like. And hopefully I can show this. All right, so we've got the same application, this one that we've done, that we've been doing. And I want to say exactly like we talked about, let's do port forward. Forward. And here's the name of the application. And I want port 5,000 to go to port 5,000 and port 6,000 to go to port 6,000. Remember, 5,000 is that JMX port. It's talking the JMX language. There's a protocol for it. It does specific things. 6,000 is effectively the debug port, Java debug wire protocol that allows debuggers to connect to a running JVM and get all that good information. And so we run this command, and hopefully it says, okay, so it's forwarding from localhost on IPv4 and IPv6, 5,000 and 6,000. Awesome. Love it. So let's take a look at, how do I hide this bar? No? Okay, whatever. Let's take a look at visual VM. So we've got port 5,000, right? And so we can add a JMX connection to localhost port 5,000. We turned off authentication, so there's no credentials. That may or may not be a good idea. Turned off SSL, may or may not be a good idea. Please be thoughtful. But we can connect, and it can connect. And when it does, you'll notice kubectl port forward says that it's handling a connection for port 5,000 because it's this application, Visual VM, even though it's connecting to localhost, like my local laptop on port 5,000, that's going up and it's talking to the Payara micro, excuse me, that is running in that Kubernetes cluster. And when Visual VM opens that up, all of the stuff that it's doing just goes up to the Kubernetes cluster, does its JMX conversations, and comes back. So then we can see things like the arguments. We can see all the JVM arguments. You can see the system properties. And you can do really fun stuff with monitoring. Like you can say, oh, here's the actual CPU activity. It's not doing anything because it's a website with no users. But here's the heap space. And the heap space is hovering around 100 megabytes, and that's really cool. A little bit of CPU usage, metaspace where you're doing, I don't know, metaspace stuff. That's pretty fun. look at threads. The thread view is actually really fun. You can actually watch these running, like the running threads that are trying to cluster, but they don't have anybody to cluster with. RMI is the stuff that we're using to do this debug, and so it's clearly running. But things like the HTTP listener isn't doing much, that sort of thing. And so this is all really cool, and is pretty nifty. One of my personal favorites is that you can actually do the CPU sampler, which will take lists of threads over the course of a little while and tell you which ones are doing stuff most frequently and what are they doing. So which are the ones that are using CPU time? It's all these Hazelcast ones, and they're inside of this NIO select loop. So you can get you can actually get like traces of what it is that your application is doing in a live sort of way. You can watch and see what your thread is up to and what it's up to most frequently. This becomes very useful if something like a web request takes a full second or so. You'll see, excuse me, sorry. You'll see those particular thread dumps show up more frequently than some of the others, just because in sampling, they will hit statistically more often. And so you'll be able to see those more frequently. And you can kind of like delve into what are the slow paths in my code through that, which is pretty fun. So here's heap, and you can see here's the heap, and then here's a GC. And then here's some heap doing heap stuff and a little GC, but it's all okay. 100 megabytes. I don't know. That seems pretty reasonable. We will leave this going a little bit, and we'll take a look at NetBeans. And here's the actual code for this application that's running. And if we say debug, and I want to attach a debugger, and this is the same sort of game here. I want to attach a Java debugger, attach it via socket, and go to localhost, and on port 6000. And I want to say, I want to attach that. It'll think about it for a little bit. And if we look at Coopctl, it should say, yep, we're handling a connection for port 6000 now, which is pretty cool. And they'll think about it, and it shows us the same thing. Like, here's all the threads. And that's really fun. But also, like, super importantly, I can do things like set a breakpoint. And I can do things like add watches. Like I can say, like, what's the value of current users? And so this little web application, what it's going to do is it's going to fake a leak, is going to start loading a bunch of data into a set that should be able to deduplicate, but for whatever reason, it won't be able to. And so this set is going to grow very large. And so let's take a look at that. When that happens, let's see. All right, so I try to get to this application, and hopefully, nope. Float demo has a leak. Oh no, I didn't do this right, did I? Yep, this is why we don't do live demos. But once again, let me show. I don't want to try to debug this, so let's go to the video. There is a delightful video here. And we're actually just going to watch this on YouTube so I can full screen it. Here we go. And so this is going to do the same thing that we did before, where we are getting pods. Yeah. We'll take a look and see what the name of the Java application is. We can see that we're using JDWP on port 6000. Set up the port forward again. And connect up the debugger. That's like we did. Cool. It shows that it is in fact handling the connection. And then you should be able to, once that's fully loaded, set the same breakpoint that we were trying to a second ago. down here on current users. Yep. Turn that into a watch expression. Wonderful. And then we can actually go to the website and see that it like the breakpoint works. Like we hit the breakpoint and it freezes execution of that application right there. So let's talk real quick. Oh God, no. No, go away. There we go. Wonderful. And I'm going to try one more time to leak. This should be. No, it's not. Okay. Okay, cool. Okay, that's fine. All right, so yeah, when that happens, you can also take a look at inside of Visual VM. You'll be able to see here's what the heap is doing, do all the thread stuff we were talking about before. Ends up working out pretty well. Ways that this can go wrong. You can't run because like you're taking up a local port. Like if you want to try to debug two applications at the same time, you can. It's just going to be a little bit harder. You can't run it twice with the same port. You can fix that. You can give yourself two different local ports pointing to two different applications outside of your local machine. So two different applications in Kubernetes, two different Kubernetes clusters, something like that. This will totally work with JDWP. You can flip back and forth and do some kind of interesting things there. JMX is still really complicated. We took a look at back here. We took a look at all of these like very long, very intricate JMX configuration options, and they are weird. JMX is definitely a protocol that was designed for a slightly different world, and especially a world where servers are not ephemeral. The name that that RMI uses and the name that JMX uses has to match what the client believes that it is. And it also has to work on the server. And so localhost is the only one I've ever found that works consistently. But that also might conflict with other tooling that needs to know the name of your application that isn't localhost. Like that really wants to know the name of like the container that's running. So for instance, like if your APM wants to be able to distinguish between different containers, if your metrics thing wants to be able to distinguish between containers, that's not going to work as well. JMX and RMI are also like a multiplex protocol on the same port, but they can also be split on separate ports. If you go and like the important part here is that if you just go and Google for like how to do this with JMX and RMI, you'll find a bunch of different like conflicting instructions, and some of them can work and some of them don't. And like just play around with it. You can get it to work, I promise. What else can we do with that cool stuff? And the answer is like more IDE integration. Like this is really fun. Just having like a remote debugging thing. But we can have an entire like development cycle that points our like locally running applications to other microservices, to other like resources, other things like that that are running in Kubernetes. And this gets to be wildly powerful. Because now we can do things like, even though you have 50 microservices to do your stuff, and you only want to iterate on one of them, you don't have to run those other 50 on your laptop. You can run those in a Kubernetes cluster, edit the one locally, and then use something like telepresence, which is built into IntelliJ. It's an open source project to be able to like forward that traffic up to the cluster and be able to reference other microservices. And then you can also do things like debug those other microservices while they're running in the cluster, and then also see like the stuff that your local application is doing. It's really, really powerful. I have not gone down this path a whole lot. I don't use like telepresence and IntelliJ, for instance, but like the options that exist here are brilliant and are totally like the next logical evolution of this process. The other next logical evolution of this process is, okay, so I've got, me as a human, I can go through and type stuff and do debugging. What can I do? Like, how can I make it to where like robots are doing this debugging for me? And they notice when a problem is happening, and they're collecting metrics when things are good and letting me have a baseline to compare against when things are bad. Like, how can I do that? And it turns out there's an entire industry for that. Application performance monitoring, or advanced performance monitoring, or something like that. APM is basically this process. You have a little application that sits next to your web service or next to your whatever that connects to JMX or connects to JDWC or JDWP, and like does a bunch of queries and pulls metrics and does all that understanding, and then formats it very nicely and shows it to you on a pretty web page. There's a whole lot of different options for this. There include all sorts of different little screenshots that you can get of things out of the Apache project, Dynatrace, Datadog. You can see heat maps and flows and things, and it's really, really powerful, especially to be able to do it over time. Because one of the things that I feel is probably particularly important about the way that debugging happens now is that debugging is not a thing that happens when there is a crisis. Debugging is something that happens over the course of an application's entire lifetime, where you have to be able to know what the baseline is, how that baseline changes with each new version of your software, with each new patch, with each new modification, with each new config change, to be able to tell what thing is different now than it was before, and what thing needs to be reverted back, needs to be improved on, needs to do whatever, right? Like that has to be part of it, and APM is a good way to do that. We mentioned sidecars earlier, and we kind of talk about like the general sort of architecture of what APM does. Remember, we talked about pods being collections of containers that perform a single business need. A sidecar container, so for instance, an APM sidecar is one of the containers that can be spun up in that pod that has the same lifetime as your application and also has access to some of its like internal ports and some of its privileged, volumes and things like that. There are some examples. Some of the big ones, getting secret configuration is generally pretty hard. You can do sidecars that do that. There are sidecars that automatically encrypt and authenticate your network traffic. And then there's sidecars that run agents that watch processes, that watch open telemetry analysis, that do all sorts of things like that. And so those can be then versioned separately from your application, where you're running your application version 1 and Datadog's APM container version 7.5, and allows you to iterate both of those separately, manage them separately, and then be able to control upgrades to them and regressions and whatnot without having to completely rebuild your application. Show the screenshots. This is still an evolving industry. It's really cool. It's really powerful. There is a small performance hit, of course, anytime you're doing debugging type stuff. Apache Skywalking claims that it consumes about 10% of your CPU, nanoseconds of latency. That's a sales claim. Like, it's probably approximately true. Sometimes you'll get weird bugs. Anytime that you're getting like deep into JVM internals and like adding hooks to things, weird stuff's going to happen. You'll run into like weird bugs, weird slowdowns. Also, memory intensive investigation, like why is my memory filling up, is still a lot harder than which of my threads is running a lot. It is tough to do sampling on the heap that is as useful as getting that full heap dump and doing like a full analysis on that. That industry is getting better, but it's still a little bit fraught. And that is everything I wanted to talk about. That is a lot of things about debugging Java applications, about debugging things in Kubernetes, about the architecture of Kubernetes. Hopefully this was a little bit helpful to you. Hopefully you got one or two things to take back to your daily life. Please, if you have questions, let's chat. I'm going to hang out here for a while longer. I'm in the Discord, Twitter, email. Like, please, like I weirdly, I love talking about this stuff. Like, it's super entertaining to me. Yeah.
Thank you.
Once again, with the slides.
Thank you, William. It's very good. Very,
Thanks.
Full of like practical guidelines and, the insights that you have from working with it. So that's wonderful. Does anyone have questions for William?
Two chats. Well, will the slides be shared afterward? Does the recording go on YouTube? Yes, the slides are available. They are here. And I believe this goes on YouTube. And then Greg in the chat asks, am I keeping up with ephemeral containers, a new feature for sidecars? I'm not entirely certain, Greg, what you mean by ephemeral containers. Are you talking about like init containers that come up with the with the application, or kind of? I guess the short answer to that is I don't know about keeping up with ephemeral containers, a new feature for sidecars.
Oh, question about maybe we can do it live about the thread dumps.
Yeah,
I know very little about the Kubernetes. Just a disclaimer, right? So I don't I mean to be an expert or anybody who knows a lot about it. So looks like if you can do that heap dump, I would assume that you should be able to also. I'm talking about the command line, right? I'm not talking about the visual tools, IDEs, etc. But if you switch back to Coopctl, whatever you pronounce it, you should be also able to do the thread dump, right?
Yes. Yep. Totally.
Can you do that?
Yeah.
I can paste you the. Okay. Yeah. Okay.
Yeah. So I can never remember exactly where it goes, but if I think it's kill-3.
You can do that, but also there's a JCM command that you use, so it's going to be even easier, right? So you find the command that you use for the heap dump.
Yep,
JCM.
you can. Yeah, there's the JCMD. Yeah, I'm used to kill-3.
Right. Yeah, that's fine. Yeah, that will also work. But let's try this. Yeah, exactly. Yeah, I was after that. Right. Yeah. So you had a command for the thread. Heap dump. We could probably reuse it to do the thread dump. I think it's possible, right?
I think it absolutely is. So I ran kill-3 against that PID that we've been playing with. And if I take a look at, and usually that outputs the thread dump onto standard error, if I remember right. So if I take a look at the logs for this application, I should see, here they are. Here's the thread dump.
Can we do it with the JCMD?
Sure. Yeah, if what exact command do you want us to run? But the short answer is yeah.
I can type it to you. I just said it. Yeah. I use it locally. JCMD, you pass the PID
totally.
of the application, right? And then you just, instead of heap dump, you just do a thread print and then redirect it to some file.
Cool.
Something like that. Yeah, yeah. I'm just curious. I think it should be possible. But with Kubernetes, right?
Yeah, this is running inside of Kubernetes.
Right. Yeah.
Yeah, as once you get into the shell, you're super powerful. Like you can do all sorts of crazy stuff, including like you can get these thread dumps. Here's the entire thread dump that you just did. Yeah, totally.
That's fine. That's okay. But I was curious if you can do this with the Kubernetes like you did for heap dump, right?
Yeah, you totally can. So,
yeah, I think it should be also possible, right? Actually,
it is. So the same thing that we just did, JCMD.
Right, exactly. Yeah.
One, and then we want to output this to.
Yeah, I think it probably. Yeah, whatever you want to sort. Yeah.
Thread dump.txt, something like that.
Yeah.
And that should work. Yeah. There you go.
Okay, cool. Okay,
and then kubectl. So like copy it down.
Okay. Yeah.
We can do the same thing that we did with the heap dump, where we copy it here.
Right. Yeah. Okay.
See, and not too many of those. And then here it is. Here's the thread dump locally.
Yeah. Kind of. Yeah. I know whatever. Yeah. Cool. Okay. Yeah. That's.
Yeah.
Yeah.
You absolutely can.
I just assumed that it was possible to do that. Okay. Quite interesting.
It absolutely is.
Yeah. Thank you.
Totally. Great question. Let's see here. I had chat. Greg posted some things about ephemeral containers, which I'll have to read here in a moment. Thank you, Greg. Greg is an excellent developer that I know from my past. Called a debug container. Now you can attach the process namespace with Coopctl debug. That's awesome.
I got a question for you.
Yeah, what's up?
What would you do for fatal error logs? Would you just say write that off to like an NFS mount somewhere? Since the container is going to die in theory as soon as that would happen.
Yeah, so for most of the fatal error logs that I see, hopefully and you'll notice that like when we took a look over here a second ago at these logs, this was coming out of standard out and standard error of the Java process. Kubectl or Kubernetes will take anything that comes out of standard out and standard error and expose it on this logs endpoint. Most often what I see happen is that something will get set up either like a Splunk or a Sumo Logic or a CloudWatch sort of thing that will take all of those logs and write them to some sort of store that can be searched later. That is generally my preference, is that, or even like a syslog target of some kind that just consolidates everything together and is outside of that that container. For logging, I think that's probably the best answer. For stuff like heap dumps, for stuff that doesn't happen on standard out or standard error, for stuff that isn't just like written out as text, so binary files, heap dumps, things like that, I do think probably the best answer is to have like an external volume, generally an NFS mount or something relatively simple like that, where systems that are dying, systems that are hitting fatal errors can dump whatever their last debugging information that they want to that endpoint.
Thank you.
Of course.
So quick question about the Kubernetes itself.
Yeah, what's up?
Get a better understanding. So what's the connection between the Docker image and the Kubernetes? That's first question. And the second one, I think you assume that the people in the audience know what the Kubernetes are and et cetera. I don't think it's the right assumption, including myself. I just heard the term anyway. So if possible, I know it's probably very difficult to answer in a simple way, but the second question is, why should I use the Kubernetes? What problems Kubernetes solves for me? Don't tell me Kubernetes itself. That just tell me what the problems it solves that I can use it, right? Because there are other tools that might do what the Kubernetes does. Yeah.
Right. Yeah. Okay. So Kubernetes is a container orchestrator, which is kind of a silly word. So let's begin kind of with your first question, which is, what is the relationship between Docker and Kubernetes? Let's jump back a little bit further and say, what's the relationship between Java and Docker, right? So
yeah, fair enough. Good. Mm-hmm.
Yeah. Okay. So as an example, this web application that I've got is packaged together as a jar file, the Java executable, a series of Java libraries that need to go in there, maybe some other jars, and then the operating system around it that wants to be able to run Java. And that's great, right? Like that is from the perspective of a piece of silicon that wants to run my application. That's all the stuff it needs, right? It needs the operating system, it needs Java, it needs my application code. All of that together. Okay. So what Docker does is says, okay, I'm going to take all of that and I'm going to serialize it all together in a single object, a single big file. And then that way, regardless of what operating system, someone's trying to execute something on, regardless of whatever, and regardless of what kind of system I'm on, all I need to be able to do is execute the things in this image, and they're all stable. They've all already been tested together. I don't have to worry about dependencies, things like that. The Docker image itself is a way to package and deploy applications along with all the dependencies.
Yeah, makes sense. Yeah, self-contained. Yeah, exactly. Environment.
Yeah. Totally. Yeah. So, all right. So now, we've got this Docker container that's running, and we've said, okay, like that's great. Like here we've done that. We are now running the Docker container. Your Java application exists. So now the question is, like, what does that mean in terms of like getting internet traffic to it, right? Like what sort of load balancers? How many copies of this application can I run at the same time? What if I'm running 4 of them and one of them dies? Should I spin back another one? If I'm only running 1, like, is that enough? And so the question of like, how do I, now that I can say on these different servers, on whatever server I want, here's a copy of my application, where do I go to the next step? How do I orchestrate multiple copies of my application? How do I get traffic to and from it? How do I configure it? So environment variables, properties files, stuff like that. And then how do I tell it about like databases and things like that? So Kubernetes comes in at that point and says, okay, you want me to run 4 copies of your web application. You want me to build a load balancer in front of it and load balance between them. And you want me to configure this application to say, here's where my database is, here's you're running in production, your name is blah, blah, blah. Like whatever configuration options you want. That's the part that Kubernetes does. It is orchestrating the existence of those Docker containers, copies of the image, right? So the image is the same, your application is the same, the code is the same. It's running 4 or 5 copies, 4 or 5 containers. And then it's distributing traffic to and from them, and it's managing them. It's making sure they stay alive. If they do die, Kubernetes will bring up a new copy and add it into that load balancer. That's the side that Kubernetes does. Does that make sense?
I see. Okay. Yeah. Great. I mean, in a software development, you can use the term glue code, right? Meaning that you glue all the pieces together.
Totally.
Framework, right? Like
yeah.
String or whatever, right? Yeah.
Yep.
So yeah, kind of analogy. Yeah. Thanks. That's very clear explanation what the Kubernetes does. Much appreciated. Thank you.
I'm glad. Cool. Yeah. Totally. Yeah, and in Java, like we're used to this sort of idea of having write once, run anywhere, right? Like that's been the promise of Java for 30 years now. You know, the idea that we have application servers that can take a Java archive, a package, and be able to run it, you know, like WebSphere or something like that, where you can take this one artifact and say, I want to run it across 30 copies, you know, get it configured, set it up, like all of that. Docker is very, like Docker and Kubernetes is a very similar sort of metaphor. It's a very similar sort of idea, and says, but instead of being Java specific, instead of being specific to running things on a JVM and class loaders and stuff like that, we're just going to package up the entire operating system, just the whole thing, and then be able to run that across whatever servers. That way we can run containers that have applications written in Java next to containers that have applications written in Go, next to Rust, next to Node and JavaScript and whatever other exciting things people decide to care about. It is that same metaphor just extended out a little bit. And I think that extension is what gives it a lot of its power.
Yeah, thanks a lot. Yeah, you
Totally.
made me look into those things. Actually,
Absolutely.
explaining them and convincing that, yeah, it's the reason they exist, and they solve a pretty important problems for you.
Yeah, for sure.
Network,
For sure.
yeah, operating system, etc. Yeah, cool. Thanks a lot.
Totally. Of course.
Yeah.
Let's see. Do we have more questions for William? I don't see any more new questions.
Chat. I don't think there's one, but nope. Okay, cool. Yeah, and I'm definitely going to look into. Looks like this Google blog, ephemeral containers. Nice. It was released this week, which I have not had a chance to read yet. So this looks really exciting.
Oh, this is okay. Oh, from Google.
Nice. Yeah, from Google. This is the thing that Greg posted a moment ago.
Oh,
wonderful. So yeah, I'll take a look at that here in a little bit.
Oh, that's right. Okay. That's cool. Thanks for sharing, Greg.
Awesome.
Yeah.
Gladly. I'm going to stop my screen sharing.
Okay, wonderful.
But yeah, I guess the last thing I'll say is I'm on the Discord for CJOG. I'm also on Chicago Tech Slack and, you know, Twitter and email and whatnot. And again, I love talking about this stuff. It is wildly fun to me.
We can tell how passionate you are. So thank you. Thanks for sharing. Yeah, this
glad.
is great. Yeah, thanks a lot. Yeah.